Okay, so welcome to day 12 of Foundation Programming. Um, to answer your question, Joseph, yeah, so class is not happening Friday. I have an event I gotta go to, so I will not be available. And then in regards to Monday, let me check the calendar. Is it Memorial Day? Uh, I wasn't tracking no Memorial Day, but I will be teaching. Yeah, it is Memorial Day. That's crazy. Are you guys doing anything for Memorial Day? If like a large part of the class doesn't want to do it, then it's fine. But uh, I was planning on teaching Monday. Okay, well, I'll be
I'll be
teaching
here.
Monday then. All right. Yeah, I mean, personally, I was in tracking Memorial Day. I completely overlooked it. So the schedule and the pace that we're going on right now is kind of based off under that impression. So it would really hinder us if I didn't teach Monday. Um, but yeah, so definitely teaching Memorial Day then. And then wow, we're coming pretty close to the end of FOP pretty soon. We're halfway through this week, especially because Friday won't be a teaching day. Um, but yeah, that's crazy. We were actually just talking. I came out of a meeting today about with the staff and whatnot, but it's got me thinking about stuff for the future for FOP. How are you guys feeling so far when it comes to FOP?
Um, I know that it's I know that it's like a voluntary course, but I do think there should be some like maybe some more structured homework. I can't believe I'm saying that, but like basically like repetition, homework or something like that that we can go over. Uh, because like right now we kind of have like one task to do rather than maybe introducing people to like different ways of doing the same thing. So like uh solve 4 plus 4 in 3 different ways, for example.
Hmm. There is talks about making this program mandatory and a prerequisite for everybody that comes in. Um, and making it more open like that, more structured. That there is that was actually kind of brought up today during the meeting. But obviously there's a process for all that. But I
That's what
agree.
I was gonna say. Was at a minimum was like maybe adding the objects and classes part, so like the intro to programming or making that like that entire week mandatory.
Yeah, there's definitely a lot of talks about where we're moving forward with all this. But there's a pipeline and schedule that all that has to go through in steps when it comes to it. The pre-work was kind of made for that for you guys to have some kind of like take home and work on your own before the
Right.
immersive program. Did all of you guys complete it? Yeah, I don't
Yes,
know.
I completed it.
Okay, I don't know how it's changed over the last year. Uh, but yeah, I mean that's good feedback too. If you guys feel like some take home assignments is good. I'm definitely gonna bring up the whole issue with uh having to take leave to try to uh make it to the FOP and work on some assignments or just work on pre-work in general. That would alleviate a lot of the issues. Personally, I would love for this to be extended a lot longer and have more work for me because more work means more money, right? So I completely agree. I would love for this to become a little bit more structured, have some more work, and that's on me. I'm constantly finding ways to improve the program. Um, and I think having some resources like that, some take-home assignments, uh, for at least, I think it would be good for every single lesson, uh, to ensure that it kind of sticks for you guys. I agree. And any subject of some resources, I want to drop something in the Slack channel. I'm not sharing them. Okay, good. Uh, one thing I did not get to share with you guys yet was some what's it called? You guys like books? Do you guys learn from books? I'm not looking at my camera, so I can't see if you guys shake your head or not.
No,
No, no books.
I'm not a big book guy. That's what we have the internet for, but
I agree. Um, I think, at least for myself, so when I started learning like programming, uh, I went to the nearest library I have, or I actually went to the Fort Bragg Library. Joseph's probably familiar with it, and I got all the coding books that they had of all languages. I'm talking all languages: JavaScript, C, plus plus, C sharp, Python. I didn't know what it did, and no one told me it was language oriented. Depending on what you were doing. And I didn't know where to start. I got them all, and I started learning from them. A specific book that stood out, which is really good, was the Python Crash Course. Have you heard of that? Anybody? Once again, I can't see you guys.
That's where I started.
The Python Crash Course? Yeah,
Good.
that is
Sorry,
by
I'm like
far-
eating while I'm doing this, but
It's
that
okay.
and then hold on, I got this bad boy too. This freaking monster of a text. Can you see it?
oh, that's
like
I got that one too. Yeah,
this one's like really good, but it's just a lot in the weeds. But
They,
it's good. I learn a lot.
they have that book at my school at the college that I went to for a bit.
Yeah, the
F oh, might be. I was just gonna say something about FOP. Like I know it's a lot, but just going through what is it, the Python Crash Course book, and then I honestly wouldn't know what to study unless I had like this. Like I know it's like a fire hose, but like I know I'm not doing this until October, but it gives me like structure. I'm like, hey, I saw all these slides and I know like object oriented programming. Like we did some examples and I got the slides now, and I'm like, all right, well I gotta learn this again. Like let me go over it, you know? Because I'm not like I think everyone's kind of the same way, but I'm not like a learn on the first time kind of person. I have to like see it once and I'm like, all right, what did I just learn? Or what did I just see? And then like go back. I'm like, all right, I remember I did that. So it takes me some time, but it's good because I would have never learned any of this stuff or even knew this was part of coding unless I went to FOP. So that is the plus side of everything right now.
I'd also say, on the topic of FOP, I like how it forces you to move along quickly because I find myself in rabbit holes of whatever the specific topic is. I got to find out everything about it. So I've been reading a whole bunch about Python objects and classes lately, and I'm like, I'm probably too far in the weeds. I'm in the diamond problem if you have like two derived classes doing multiple inheritance deriving from the same base class. Like I feel like I'm too in the weeds, but FOP makes you move kind of fast, so you get the broader picture of things. So that's good for me at least.
Yeah, that's awesome. No, I completely agree. FOP is very quick. It's like a crash course, a mini crash course to kind of baseline you pretty quickly. And we focus, and it's gonna be very similar with uh the immersive program. It's the meat and potatoes of what you need to know, right? There's obviously so many other things you can know about Python, JavaScript, um, APIs, right? Cloud applications, HTML, CSS. There's so many other things out there. And then what we're going to start talking about today, data structures and data algorithms. There's so much to know, but we're going to cover like the core stuff that you will see the most often. And immersive program is going to be very similar, where they're going to teach you what you're going to be doing in the real world, and they're going to leave all the other fluff out. And if you guys are interested in all that fluff, that you're more than welcome to find it, and we kind of guide you towards like where you can find these things, the documentation, how to research this stuff. But we're empowering you with the ability to be able to do that, but also know enough so you know what you're looking for, if that makes sense. Right? Very similar to like how I said when I first started off, I didn't know these languages were specific to what you were doing, right? I didn't know what different types of frameworks were for what, but knowing enough of a certain amount of subjects is it gives you that ability to know what to look for to find the right answer to move forward and build upon it. I just dropped a book. This isn't the one I was mentioning about the Python crash course. This is going to be a book that I highly recommend for today's lecture and for the remainder of FOP. Today, once we conclude the last assignment for what you call it, read and write files, we're going to begin data structures, data algorithms, big O notation. And this book right here that I just dropped in the FOP Slack channel is like a Bible for this, if you will. It breaks it down like dummy simple. I'm kind of dumb. And it has nice pictures. And not just any pictures, it's pictures of rats. So it's pretty cool. Breaks it down very simplistic, uses very like simple words. And that's not to insult anyone's intelligence. I love the book. Like it worked for me. Especially once we start talking about some of these data structures, data algorithms, it can get very confusing. So if you struggle with any of it, this can break it down, especially subjects like recursion, uh, logarithmic stuff, and whatnot. If you don't understand the concept of like big O notation, which we'll talk about, I'll explain that to you very well. So definitely keep this book that I just dropped in Slack in the back of your pocket. And if you ever struggle with any of these data structures, data algorithms, break this bad boy up and it'll open it up and kind of explain it for you in a very simplistic manner. And then once I find the Python crash course, if you guys are interested, especially if you started with JavaScript and you struggle with Python, the Python crash course is very helpful. If you like a hard copy, then go to your library. They typically have it. Also, Barnes and Noble has typically in their coding section, computer section, they have the book as well. I always see it there. So check out Barnes and Noble. But yeah, I feel like I got off on a tangent. Yeah, so usual resources, books they help me a lot, right? I enjoy tutorials. I like people talking to me, but sometimes it's kind of hard trying to follow a video. You know, having that book next to me, right, as I'm coding, step by step, it's extremely helpful. And just the hard copy itself is nice, especially when you're not looking at another screen. But all right, moving forward, we're going to pick off from where we left off yesterday. We have one last assignment that we didn't get to yesterday. We'll do that for the first hour, which is actually not going to be an hour. It's going to be like 30 minutes. We'll go over it, go on break, and we'll begin the next lesson for today. All right, if you go to the repository, you'll find pets. That's going to be the next one. All right, you're going to import your JSON module, and very similar to the SAT, that you're going to create a class, right? A class named neighborhood pets. That has different methods, one for adding a pet, deleting a pet, searching for the owner of a pet, as well as saving your JSON data and loading it, right? That should all be within its own individual method. And then it'll tell you step by step, right? You will also have to create or raise a duplicate name error, right? So if you guys remember on creating a class for your exceptions and then making your own exception. There you go. So you're gonna have to do that as well. And yeah, so we'll do that for the first part of our class today, and then we're gonna close the page on reading and writing, and we can move forward with the rest of the lesson. So go ahead and take that time. We'll stop around 6:10. So we get 10 minutes to go over it and then 10 minutes for break. And go ahead. Can you guys see my screen? Should be
Yes.
empty VS Code. All right. We're gonna go ahead and go over this real quick just in case you guys had any issues with it. All right, so for this project, we're gonna have to import JSON. So the very top, like usual, we're gonna import our JSON module, which is gonna allow us to use the .loads and .dumps method. Let me increase this window. All right. Now we're gonna write a class named neighborhood pets that has methods for adding a pet, deleting a pet, and searching for the owner of a pet, saving data to a JSON file and loading data from a JSON file, and getting a set of all pet species. It will only be loading JSON files that it has previously created. So the internal organization of data is up to you, right? So that was where that JSON file came from. So we're gonna go ahead and create our class, which is gonna be called neighborhood pets. And then we're gonna define an init method. The init method takes no parameters and initializes all data members, which must all be private. So, let's see. All right. So for the init method, we'll do something like self dot all pets, and we'll initialize an empty dictionary. This is where we store all our pets at. All right. Then the add pet method takes the parameter, the name of the pet, the species of the pet, and the name of the pet's owner. All right, so if a pet has the same name as a pet that has already been added, then the function should raise a duplicate name error. All right, so up here, we're going to create class duplicate name error, and it's going to inherit from the exception class. We don't need to do anything. We just want to be able to raise this duplicate name error. And now we can create our add pet method. So we're going to define add pet. Oh, Jesus. It's going to take in self name, or we do pet name, pet species, and pet owner, right? Now, if a pet has the same name as a pet that has already been added, the function should raise a duplicate name error. You need to define the exception class. So we're going to take these parameters and we're going to check if it's within our self.allPets dictionary. And if it is, we'll raise the exception. And if it's not, we should save it. So if self.allPets, and then we're going to grab a pet. We will grab it by, actually, we can just do if pet name in self.allPets. Because it's a dictionary, so we're able to use the in method without having to do any crazy looping. All right. If it's in there, we're gonna raise duplicate name error. And then here we can say pet name already exists in the neighborhood. Else, then I want to save it. Pets, pet name as a key. And we can assign the values in here. We'll do a dictionary with value as dictionaries. We can do species and assign it the pet species parameter. And then we'll say owner and pet owner. Cool. So that should save it in our dictionary, right? Now that takes care of the adding. Next can be delete a pet. So we'll do define delete pet. We'll take in self. As a parameter, it's going to take the name of the pet. So pet name. And then, is there anything else specific to set? No. Okay. Well, we can do if pet name in self.allPets, then we want to do self.allPets dot delete. And they should delete the key value pair from the our dictionary. Or actually, I think for dictionary is delete. I'm pretty sure it is. All right, that should delete the key
So-
value pair.
Just out of curiosity, do you know what happened if you tried to delete something from a dictionary if it didn't have that within itself?
You might get an
So if you didn't do
error,
the if check, okay.
uh, which is why we're doing the if check. But in the event that we don't find it, then we'll raise another exception. We can do something like class non-existent pets. Now, this wasn't an assignment, but we could do that ourselves, right? So we can raise an exception. Right, so we can get some feedback. Pet name does not exist. Or pet does not exist in the neighborhood. There we go. Okay, yeah. So if it's not existing there, we will raise an exception. But because we did an if check, if we don't do this, we might not receive any feedback. We can also print something out here. Pet has been deleted. Just so we know that it actually worked. All right. So that takes care of the delete pet. Next, gonna get the owner, takes the parameter, the name of the pet, and returns the name of its owner. So we can do define get owner self pet name. And we'll say if pet name and self dot all pets, then we can return self dot all pets. We'll grab the pet name. And then it should return a dictionary, right? Because of how we declared it here. So we can just make a quick note here. Key is pet name. Value is dict. So we know it's a dictionary. But because it is a dictionary, once we grab that value, now we have to go even further inside of it. So we want to grab owner. Right? Else, we can do class non-existent parent or owner. Exception pass. And we can raise non-existent owner. Pet does not exist in the neighborhood. Right? Yeah, so cool. Let's print the owner. I want to see it. Why is this not working? Code is unreachable. Oh, because it's returning. There you go. Pretty dumb. Okay, we'll print it out. Just get so we don't have to save it in a value and print out in our code. Too easy. Next is going to be the save as JSON and read JSON. So the save as JSON method should take a parameter, the name of the file, and saves it in a JSON format with that name. So we do define save as JSON. We'll take in self file name. With the name, you can assume the extension, if any, will be the part of the provided name. Will be part of the provided name. You can organize your JSON file name however you want. Okay, so you can just say with open file name. We would have to essentially format it to make it JSON. So we can say, we can do like some string interpolation, right? So we'll say file name dot JSON. We're gonna want to write inside of here. And then we say as out file, so we're trying to write into a file. And then once you do that, we can actually save all our data in there, right? So we'll do self dot all pets, and then we'll do is equal to JSON dot loads or dot load, and then the file we want to save it into out file. And then yeah, it should create the file. We can print it out too if we want to see it, but it should create the file for us. What do you read as JSON or read JSON? Self file name. All right, so the read JSON method takes a parameter, the name of the file to read and loads that file. This replaced all the pets currently in memory. Okay. So with open, we'll do formatting file name dot JSON. We want to read as in file. Self dot all pets equal JSON. Oh my bad, this is dump. So we want to dump it into the JSON file. Thing no caught that. This should be dot load in file. Right? So one loads, one dumps. Let's see. Actually, we don't need this. We are gonna load self dot underscore pets, and then let's add the indent and set it to 1. So it looks pretty. So 1 will dump it. What are we dumping? Pets into out file, and then we're going indent by 1. Okay, so we got that, and then get all species method takes no parameters and returns a Python set of all pets. Research what it said is, and we haven't covered in class. All right, we'll do a list. Define get all species self and then return. So we want to grab all the stuff. So we'll do all species. And then we'll do for pet, or I guess self dot all pets. In for pets and self dot all pets. We're gonna look through it and then add them into the list. How do we want to add these? Do we just want to grab species formatted by name, or does it have explanation? No. Okay, we'll just do all species dot append pets, and then we want to grab species. That's how we saved it. Yeah. Return all species. All right, cool, whatever. Continue on. It's already 6:24. Okay, let me see if I can get these real quick. Okay, we'll do NP for neighborhood pets. That should instantiate it, and then just print out or add this. So add pets. Whiskers, the cat. We have new students here, so we'll say Joseph. because we got cats. Fetal lice, the dog. We'll say that Eric. That's just what makes call the dogs fetal lice. All right, and then we got Brandon. He talks to his bird called Max. Yeah, so that should add the pets. And then let's do np.save as JSON. We're going to have a file name, so we'll say this neighborhood pets. And then per our method, it should add the .json to it. We'll do np.read JSON. Actually, let's do this first. Quit. There we go. DDFP. And then we want to go into lesson 11 and then text. Okay, Python text.py. All right, so on the left side, this just populated. Let's open it up. Oh, we have one pet name. Okay, we said this wrong. So up here for the all pets. Okay, I see. We want to add this to. We want to change this to pet name. All right, not the string pet name. That's what we got here. So it should update it. There we go. So it saves Whiskers, Fetal Lice, and Max as the key, which is essentially the pet name, and then value is the species and the owner. Cool. All right. Well, let's check our read JSON. Well, this won't do anything unless we change some stuff in here. We'll do so Joseph. We'll say Sam instead of Eric. Actually, Eric got a new pet, no longer fetal lice. We'll call this guy. He's got a Chihuahua. We'll say his Paco.
Dachshund.
Paco. So we should be able to do np.read JSON. We want to read neighborhood pets. And then let's print out we changed species, so let's change this as well. You no longer have a pet dog. You have a what's another pet people have? The fish named Paco. And then Brandon, you got rid of the bird because he kept you up all night. So we'll say the ferret. Which should now allow us to do np.get all species. And this returns all species. We're going to print it out anywhere. Print. String indices must be integers. String indices must be integers. So we're getting pets and it's returning bird. We're appending that into our list. Why is it being picky? for self in the pets, this is a dictionary, so let's go with items for all species. Yeah, we should be able to do items for pets. We're gonna do dick, pen, we'll do self dot pets. I'm gonna grab it by the pets. And that should grab the species as well. So, all right, so we're looping through a dictionary. We're grabbing the key value pairs. Then we're gonna grab the pet and the species. So now this should work. There you go. Cat, dog, bird. That's wrong. This needs to read our JSON file and load it into self.pets, but it's not doing that the right way. Why? Because the read JSON method takes from the name of the file to read and load the file. This will replace all the pets currently in memory. But it's not doing that. Okay, let's do some research. Let's stop the recording. You guys can go take a break while I do some research real quick of why it's not doing what it should be doing. And we will continue afterwards. All right, let's go ahead and come back. So some quick links to the code. Update on delete pet. Line 28. Before it did not have the key of pet name. So if I would have deleted something, it would delete the entire dictionary. So make sure you guys do correct that if you guys are crawling along. And then in regards to the JSON file not being formatted. So this is what it essentially looked like when we first ran it. And then we changed something. We changed the species, right? Max is supposed to be a ferret. And Eric has a fish named Paco. It's a catfish with nice little mustache, so it fits Paco. And then when we ran it, what happened? Well, it overrode what was in here because when we ran the code, we have line 56 running again, therefore saving this back to what it was and printing out the exact same thing. So if you wanted to run this again, we would essentially have to comment this out. Now, when we run it, it should grab what's now in the JSON file, change what's actively inside of this dictionary, and essentially override it, right? Actually, we don't have to do all that. We just got to override the save this JSON file. We want to delete this. All right, so this will essentially recreate this dictionary. All right, when we instantiate this neighborhood pets class, it'll recreate the dictionary. We'll print out the species, and just actually we'll print out the entire dictionary. And I know we're not supposed to do this, but I'm gonna do it anyways to avoid time and more coding. I'm gonna go ahead and print out what all pets is gonna show, and it should show all of this. Once we import what the JSON file has, which is different, it should give us an updated species list. This MP.all_pets is not callable. We should be able to do that. There we go. So it's not a method, it's a data member, so it doesn't need the open and close parentheses. So we see the first dictionary it prints out is what we initially had, which was whiskers, feudal eyes, and who else? Mats, right? Which they were cat, dog, and bird. And now we have cat, fish, and ferrets. All right, so that's what happened. The code wasn't wrong. Essentially, we were just still running the exact same command before. Therefore, undoing any change we made to the JSON file. Cool. All right, that's going to conclude this lesson. We're gonna go ahead and move forward. I think that's enough of reading and writing files. It's time to take it up a notch. Please just come back to the camera if you guys are there, and we'll move on with the lesson. All right. Share. All right, cool. Lesson 11, Big O in common problem solving patterns. Say goodbye to anything involving JavaScript, HTML, all that, objects and classes, and the files. Now we are going to get into data structures, data algorithms, and all that fun stuff, all right? If you guys recall from a previous conversation we had, there is a distinct difference between software engineering or development and computer science. All right, if you guys have gone through a computer science degree, first of all, they focus a lot on Java. But a lot of it is also about the science behind computers and data, which is cool for the interviews, but you don't really learn much about the actual software development part. And you can speak to a lot of people that have gone through their CS degrees. They don't learn what you would learn in a coding bootcamp. And we're gonna cover a little bit what you would learn in a CS degree, which is your data structure and data algorithms. Enough so you guys can kind of go out on your own and do your leak code and kind of start trying different things and solving some of these problems. And the first thing that we're gonna cover is gonna be big O notation. So how to judge if code, how to judge code quality, right? So imagine we have multiple solutions to a coding challenge. How do we decide which is best? Who can answer that question?
Can you repeat the question?
On the slides, can you guys see it? Am I sharing? I'm sorry.
Yeah, I got it.
Yeah, I see it.
Right. So your code. How do you judge which code is better? Right. If I had to compare Joseph's code to Eric's code, which one is essentially better? What is the deciding factor?
The
Uh,
speed, space-time complexity.
Speed and memory too, right? Because
Uh,
there could be a trade-off there.
yes. So before, if we would have asked this question like 20 years ago, space complexity or memory and memory allocation would play a huge factor. But thanks to ingenuity and advancements in technology, what used to cost a lot with memory is now pretty cheap, right? If you guys remember your old PlayStation 2 days and you were buying memory cards, SD cards, so you can save your save points. Those bad boys were like $50, right? They were expensive, right? Even USBs were pretty freaking expensive. To buy a 1 terabyte hard drive was super expensive. Memory in the past was very expensive. And nowadays you can buy a 1 terabyte for pretty cheap, a whole terabyte for probably like 15, $20, right? Before that would have cost you easily somewhere between 50 and 100. Now it's not the case. So space complexity, does it play a factor? Yes. It's not as important though these days as much as time complexity. right? And your time complexity is how efficient your code really is, right? If you were to go back to some of your coding challenges that you did during your assessment, you would be pretty surprised with the time complexity your solutions had. A lot of you guys be, nested for loops, loops within loops within loops, uh, making it absolutely horrible. It worked for what you were doing, but in a real world scenario, you would want to make it a little bit more efficient, right? It got you into ColdPlatoon, but it's not enough to solve a real world solution. So we're gonna talk about code quality, uh, time complexity, and space complexity. Here you see a nice little diagram, what you're gonna see pretty often throughout the rest of this lesson, of the complexity from most efficient to least efficient, uh, most efficient being constant, and so on and so forth, right? So big O is a mathematical notation that allows us to compare algorithms to one another. Yeah. Why is this important? It's important to have a precise vocabulary to talk about how our code performs. So it adds certain terminology. It's useful for discussing trade-offs between different approaches to a given problem. At bigger companies, you will be dealing with very large data sets where the implementation of one algorithm over another might save you a couple hours every time it runs. Uh, Whereas here, during uh, the course, you're dealing with simple stuff like arrays and whatnot of like maybe 10, 20 things, and then whatnot. Other places, you're going to be taking in a lot of data, hundreds, if not thousands of different data, whether if you're, for example, working with like the login screen of a bank, right? Keeping track of thousands, if not millions of different users they have with their login information and whatnot. That's a lot of data to go through, parse through, and manipulate. And that's where it really plays a huge factor, right? So we want to write a function that doubles the integer that is passed in on this example. From looking at this, which one of these functions would you say is better?
On the right.
Why?
Less lines
you
of
don't.
code.
Yeah. You don't have to loop through 0 and 1 to come to the answer.
The loop, correct. It's not necessarily the lines, it's more of the loop, right? Of what you're actually doing. Right here on the left, we are taking in a random argument, which is num. Could be anything. It could be 5. It could be 1,000, right? And the biggest issue here is this for loop. We're looping through the number, right? The size of this number. As mentioned, if it was 5, it's probably not that bad, right? 5 is cool, but the issue would be if whatever you're looping through could be 1,000, 500,000, a million different things, and it would take that many steps to do that one function, right? To get the same solution you would if you just got the entire number and just multiply by 2, right? Here, this is pretty constant. You just grabs that number. It's very instantaneous and just multiplies it by 2, giving you the exact solution. Whereas here, to reach the exact same result, you're having to loop through as big as what this number is. All right, so yes, the right is more efficient. The more better, more better. I don't know. I don't know that's the thing, man. English is my second language. Solution, right? What do we mean by better? Right? By better, do we mean what code is faster? Which one uses less memory? Or which one is more readable or even less lines of code? What do you guys think?
I think something that is legible to all programmers would be probably the best because like let's say it's more universal, right? So like if you are tasked with making the code more efficient, going into that code as someone who's never worked with it before and being able to read it is far better than going in and seeing like a confusing code base.
Yeah. I believe it's a mixture of all three. Right? Which one is better? And how do we know which one is better? Is one is just like Brandon said, being able to read it, right? So other people can pick up your code and understand what it's doing. It's not confusing, right? There's lack of documentation. It's just nested loops with different variables with bad naming conventions, right? Same time, we want to ensure that it is efficient and it uses as much memory as possible. Even though it's not as relevant these days, it's still a factor that we take into consideration. Let's talk about which is faster. If two different people run the exact same function on two different computers, will they get the same time?
No, they won't.
They would not. What if the same person runs the same function on the same computer on two different days? Will the runtime of that function be the same?
No.
Negative. It would not. Right? It does not matter. We do not base it off of time, of how fast it runs, time-wise. Computers are all different with different types of hardware, and they're not always consistent, right? Even though it is the exact same computer, you run the exact same program, same functions, you will more than likely get a different answer every single time you run. I'm sorry, not different answer, a different speed, right? I want to make sure I say that. The answer will be the same. The function still will be the same, but the speed of how fast, how long it took, time-wise, would be different. Emphasis on time. Why we don't use time? Different computers will record different times every single time they run it. Even the same computer will record different times. For very fast algorithms, the time measurements of the computer might not be precise enough, right? So we do not measure efficiency by time, right? We use steps, right? A way of saying it would be steps. How many times it took to do something, right? How many iterations, right? So steps or iterations, right? You can use those words interchangeably in this context. Not time, but iterations. Instead of measuring time, we count the number of simple operations the computer has to perform. This number stays constant across all computers that run the same bit of code, right? This function is only one operation, no matter how big num becomes. Whereas the other example, if we are looping through, depending on the size of what num is, we will have to do that many steps, whether it's 5 or a million, right? But this code does not matter how big that number is, it will always do one iteration. It's just gonna multiply that one number by 2 every single time. The other one is constantly doing different iterations to reach the exact same result, and that is not what we want.
So that means that last code before, that would have been O of N, where N would have been the number of operations,
Iterations.
depending on how big that number was. And then this one would be O of 1, because there's only one operation.
Correct.
Okay.
Compare. How many operations does this function run if num is 10? Not a trick question. 10 operations, right? It would have to
10.
do the 4 in range and add 2 to it 10 different times, right? What if num is 1 million? It would do 1 million iterations. Specific number isn't that important. The only thing that matters is a rough estimate. For this function, the number of operations grows roughly proportionally with num, right? So depending on the size of num, whether it's 10 or a million, it's all based of how big that number is due to the fact that they're using a 4 in range of num. Big O, simple definition. Big O notation is a way to formalize fuzzy counting, right? It allows us to talk formally about how the runtime of an algorithm grows as the input grows. Specifics don't matter as much as the broad trends of the function in question. Here is another version of that nice little graph you guys have on the input size and the computations of your code, right? And how it matters over time. Constant stays the same every single time, no matter how big the input size is, it is still constant, is instantaneous, one operation, right? Logarithmic, O log of n, actually becomes more efficient the bigger it is, right? And you kind of see that here, and the Grokken's algorithm book does a great way of explaining it. It essentially works very similar to kind of like dividing and conquering, right? Whereas, for example, let's say if I wanted to find the number 7 within the the numbers 1 through 20, right? The way that log of n works is it breaks that bad boy in half. It checks both halves, which one is 7 greater than what the halfway point is. Let's say the halfway point is 10. Is 7 greater than 10? No. That means every number that comes after 10 is now out. I just cut that in half. Now I check. I cut 10 in half. From 1 to 10, I cut 10 in half. So it gives me 5. Is 7 greater than 5? It is. So every number that comes before 5, gone. Or every number from 5 before is gone. Now that's 2 steps. Now I'm on step 3, number between 6 and 7, right? What is that? The halfway point. It is 8. Is 7 greater or less than 8? It is less. So the number 8, 9, and 10, gone. So now I have to check 6 and 7, right? What is the halfway point of those? And then you figure out if it's greater than that or not, and it leaves you with an answer. What might have taken you multiple iterations, let's say you looped through, right? You did O of n. It would have taken you 7 steps to reach the exact same result. Log of n allowed you to reach that within what, 4 or 5, right? It was faster because of the way the log of n works. And it becomes even more efficient the bigger it is, right? Imagine trying to find the number 137 out of 1,000. You cut 1,000 in half. Is it greater or less than 500? It's less, right? That brings you to between the numbers 1 and 500. Is it greater or equal or greater or less than 250? It's less. So you cut that half. That's 2. 2 steps, and you've eliminated 750 steps out of the equation, right? Now you're checking if 137 is greater or less than what's half of 250? 125, right? Is 137 greater or less than 125? Well, it's greater, so you cut everything before 125. And you're significantly just chopping off all these other steps to find that answer. So what would have taken 137 steps if you use O of n, right, a loop, you almost at the answer with the 3 steps, right? And that's how log of n works. The bigger the what you're trying to find is, the more efficient it is. The bigger the input size, right? So that's why log of n, you see that as the input size is increasing, it's taking less computations over time. O of n, as the input size increases, the computation increases in the exact same rate because it is equal to how many items it has to loop through, right? So we have if the input size is 10 items in this list, then you have to do 10 computations max, right, to find the answer. If it's 100 computations max. Make sense? And that's kind of how it works. N log of n gets a little bit more confusing. We'll get to it in a bit. Same thing with quadratic and whatnot. Back to our 2 examples. Right, big O of this function is O of n. Thanks, Joseph. Big O of this function is O of 1, right? O of 1, because it took 1 iteration to receive the same output you would have if you would have done it in this manner. O of n being the number of iterations it had to go through. The number of iteration is the same as the size of the input. The size of the input could be either 10 or a million. Therefore, n stands for the number of iterations. And when we talk about big O notation, we talk about worst case scenario. Let's say we're trying to find the number 5 out of a list that holds numbers 1 through 10. Sure, it might take, you know, 5 iterations, but we don't compute for, that, the fact how many it's gonna take. It's gonna take overall, right? So we're looking, ON is worst case scenario is gonna take all 10. Because what if we're looking for 10 out of a list of 1 through 10, right? So we always look for the worst case scenario. That's kind of what O of N stands for. Number of iterations total. It's gonna depend on the input size of what you're working with. Here, O of 1, and no matter what's worst case scenario, it's always gonna take 1 iteration. Broad trend example. So here we have, I don't even know what, oh, okay. Here we have a for loop. We are looping through whatever num is. We'll say 10 for example, or we'll say 5. We'll keep still, verify. All right, so for up num in range of 5, I want to print up num. So what is this going to start off at?
Could you repeat the question? Sorry.
For up num in range of num, I want to print up num. So what kind of input or output is this going to give me?
You like 1, 2, 0, 1, 2, 3, 4, 5, the range of how many, if it's like a list or if it's like a number, it'll give you that amount back.
Yeah, I'm pretty sure this will give me 0, 1, 2, 3, 4. I don't think it gives me 5.
Yeah,
It's not gonna give me 5.
whatever num is.
Yeah, so it'll be 0 through 4, right? And it's gonna be O of N because it's gonna be the number of iterations of whatever num is. The input size of this will affect how many iterations I have to go through, being O of N. This one is doing the exact same thing, but it's counting down. In range of num, right? I'm gonna go backwards. All right, I'm starting the end, and I'm going to decrease the count by 1 every single time. I'm sorry, let me rephrase that. I'm starting, if this is 5, if num is 5, it's passed in here, this will start at 5, and I'm gonna go up to -1, and I'm gonna decrease my steps by 1. So that means it's gonna count from 4, 3, 2, 1, 0, right? And it stops at 0. That's what this is gonna give me. But this is O of N as well. N being the number of iterations, whatever 5 is. Because it could be 10, it could be 20, it would have to do it by that many. Right? These are 2 for loops, all within the same function. Is this O of 2N? What do you think this would be? I'm sorry, Sam.
2n like times. Oh, can you hear it?
Yeah, I can hear you.
Every time you try to talk for the first few seconds of you talking, it sounds like you're muffled.
Yeah.
And so it might
Yeah.
be. It's my house doesn't have AC right now. It sucks. But I think it's not O2n. I think it's more like O n plus 2, like just 2 functions. I don't think it doubles that n, if that makes sense. That doubles the time.
It is O of N. It is not O of 2 of N, and it is not O of N square or anything crazy like that. It is still O of N. It does not matter if there's 2 for loops right here, right? The number of iterations it's gonna do is always gonna be equal to what N is, right? This, if it was O of 2N, what does it say? This is still O of N, technically, right? All it's doing is multiplying whatever the number of iterations is doing by 2, but therefore it's still O of N, because it still has to do worst case scenario, right? That many iterations, still O of N, right? The complexity is on the input side. It's only going to do as many iterations of whatever num is, even if there's 2 for loops side by side like this. Everyone's trying really hard to be like, what? I see you focusing. Alright. A bit misleading. We care about number of operations and not time directly. So what is the time complexity of this function?
Probably pretty high because it's a nested for loop.
It is a nested for loop. So what would the big O notation be? What's up? Remember, you gotta speak for about 2 seconds before we understand what you're saying. You're muted, Sam.
Just took out my headphone. Can you hear me better now?
A lot
yeah.
better.
Way
Yeah.
better.
I think it's ON. Or yeah, isn't ON like the lowest?
It is O of n squared, right? What is square doing?
It exponentially exponentially, I wouldn't say doubles, but it exponentially like increases the time. So
I'm
it
kinda
times
dumb.
itself. Yeah.
Right? I do mention I'm kind of dumb. So it took me a while to understand, right? But it's O of n squared. Because for, let's say the num is 10. For every single number in this range, I'm gonna have to do those many iterations to reach the result, right? O of n squared, you're multiplying, let's say if it's 10, or you're doing we'll try that those many iterations to whatever the iterations that is. Right? Does that make sense? Let me sure I'm not confusing myself. Yeah. Quadratic.
So
So
is
what
it
happens
like
is, what's up?
oh my bad. I just had a really quick question. So like, is it like I would say like list comprehension and all that stuff like cuts down that time because it what is it? Like that's like those specific examples where a million different codes can work, but then when you start simplifying things like list comprehension, and I know when I look at Stack Overflow sometimes like the algorithm or whatever, it's like this freaking long while mine's like this freaking long. Is that kind of
Mm,
like what counts down the time and things like that makes it better? Is that where that comes into use?
no, not
No?
no. It would still do the exact same thing. Right? So what's happening here, and this is 10, right? For I in range of 10, I'm going to start at number 1. Or actually it starts at 0, right? Because it's 0 and up. So I'm gonna get 0. That's the first I, right? And then every time I'm looping through that range of num, I have to do something every single time I grab one item. So I'm doing 0. And then once I get that 0, I go into the next for loop. And I do for j in range of num again. So I have to get 0 again. And I'm printing out I and j, so 0, 0, right? So this for loop is done. But then it goes back and it has to reset, right? So this is still 0, but this is not done with the entirety of the for loop. So what's the next one in this number? It's 1. So it's going to print out 0 and 1, right? I'm still not done. I'm still looping through in the range of whatever num is. So this goes to 2. I still have to print out again 0, 2. All right, and it's going to do that all the way until it reaches 10. Once it reaches 10, then the outer for loop is able to increase to 1. So for every single number that I loop through in the range of 0 to 10, right, I'm doing those many iterations again. So it's O of n squared.
So whenever you do something, whenever something does something to itself, that would be O of 2.
Essentially, yeah. Oh,
Okay.
no, O of n squared, right? O
Yeah,
of n to
O
the
of n
power of
squared.
2. Right? Because it is dependent on the size of the input. So this is 10, this is 10. And for every single number in the range of 0 to 10, I'm having to do the exact same thing from 0 to 10 within this nested for loop. Right? So let's draw this bad boy out. Oh, I already have it here.
Could I, so, is it likely that in a lot of cases, O squared or O of n squared would be the least complexity that you could get your code to? Like,
No,
are there like,
continue.
so I'm trying to wonder, like, is there always going to be a way to get my code down to O of N?
There's ways, yes. We're gonna talk about those. Okay, so that for loop is gonna grab the first item, right? And then that inner for loop is making it loop through again and print out the exact same for loop. Right? Let me delete this one. Delete this one. And then we're printing 0 and 0. Right? So it loops through first. It does for I in range of num. Let's say num is equal to 10. Right? I is gonna grab the first number, right? It's gonna start at the very beginning, so it's gonna grab 0. And then it did another for loop, right? Within that nested for loop, we have for j in range of num again. Num is still equal to 10. So once it grabs that first item, which is the first I, it's going to go into a nested for loop. And it's grabbing each. How do I? There we go. Right. For I in range of num, which is 10, is going to grab the 0 first. And then this next for loop is starting at 0 as well. Right? It's going to print out 0, 0. Once it grabs the first 0, what is that doing? It's going to move on. It's going to go to 1. So it's going to print out 0, 1. Right? We're still within this for loop. It's still on 0. It has not completed the second inner for loop that's been nested. So after it gets 1, it's going to go into the next one. And it's going to get 2. So it's going to print out 0, 2. Right? And it's going to do that all the way until it reaches the end of its range. Right? That's what j is. J is the second number. Once it does that, well, we just finished this iteration for this inner loop. So finally, 0 can move on to 1. And then it resets again inside the inner for loop. It does for j in range of num. So what happens to j? Well, now j becomes 0 again. Right? So then next time the outer for loop loops around, it's going to be 1 to 0. And it's going to do that until it gets all the way through this range. Once it does the inner for loop, then the outer for loop is able to move out. Right? And it's going to keep doing that over and over again until it reaches the outside of this for loop. So how many iterations did it do? For every 10 iterations that we did, right, on the outer for loop, it did that many iterations in the inner for loop. So 10 times 10 is 100. So in total, it did 100 iterations. Because for every single number that we looped through, we did those many iterations in the inner for loop as well. Because we were looping through in a range of 10 every single time for both. Right? Does that make sense? That's why it is O of N squared. Because it's doing those many iterations for both. Because both of them know. Make sense? Nested loops. How many operations does this function run if the num passed in is 10? It's going to perform 100 operations. So if num is 10, right, we're looping through 10 on the outer for loop, and then we're doing the exact same thing in the inner for loop. It's going to run 100 times. That's O of N to the power of 2 time complexity, O of n squared, right? O of n to the power 2. Right, because it's gonna loop through 10 times, and every single time it loops through, it's gonna do this 10 times. So 10 times 10, 100. Make sense? O of n squared. All right, another graph. I told you guys gonna see this graph a lot, right? Pretty much the exact same thing we covered earlier. It just kind of shows you in a different scale. You can kind of, this one isn't the best because O of n is down here. O of n should really be right here. So I'm not too happy with this graph, but yeah. Simplify big O notation. Remember broad terms? What happens to the number of iterations as the input gets really big? Right. So here's some tips. Constants that don't matter. Right. So 2n, right? 2 loops. What you saw earlier. Right? Not a thing. It's still gonna be O of n. What if we have a set number? It's not, because right here, n can mean anything. It can be 5, it can be 1,000, it can be 1,000,000, which is why we use n, because it's number of iterations. We don't know what it is. But here, we do know, right? It's not an imaginary number of iterations. We know it is 500. So we know it's going to take 500 iterations, so it's O of 1. This will stay constant the entire time. How about this? This is saying there's 13 nested for loops, right? 13 times number of iterations to the second power. It's still going to be O of n squared. Doesn't matter if there's 13 of these bad boys, it will still be O of n squared. Very simple to how, same thing with the regular for loop. Doesn't matter if there's 2 for loops, it's O of n. Smaller terms also don't matter. O of n plus 10. It is still O of n, right? Because this could be 1,000,000, this could be 1,000, this could be 10. Even though you're still adding 10 to it, we don't know for sure how many iterations it'll go through. It'll still be O of n. O 1,000 n plus 50, same thing. There's a 1,000 for loops, right? Each of them, we're increasing the count by 50. It does not matter. Still O of n. Here we have a nested for loop, O of n squared, plus 5 for loops that are not nested. And then another input of 8. Worst case scenario, O of n squared. Right? Make sense? The O of n squared trumps everything else. It's gonna be the worst case scenario. Time complexity, O of n squared. Arithmetic operations are constant time, O of 1. You saw that earlier with the multiplication of what num times 2. It gave us a total, right? O of 1. Variable assignment is constant time. Accessing elements in an array by their index is also constant. Same with objects in dictionaries. Keep that in mind. In an array by their index, not a for loop, by their index. So a list of 3 different names, right? Joseph, Eric, and Sam. If we're trying to grab the name on index 1, it is constant because we're going straight to that index, right? That is O of 1. If we're looping through the for loop, it'll be O of n, right? Looping through the list until we found Eric, right? But using it by index is constant time. Same with objects in dictionaries. Why? Because of the keys, right? We use key in bracket notations. it's pretty much a reference to the location of where the memory is stored at. So um, it is constant. And loops, the complexity is the length of the loop times the complexity of what happens inside the loop. Short quiz. What is the time complexity of number one?
All of it.
Then
O of n. What about number two?
O of n
O of
squared?
n.
No,
Just O of n.
just O of n. Right? Does not matter. Let's say n is like, num is equal to 10. It could be 1,000, it could be 1,000,000. It's still gonna be O of n. All right. Number three,
All of one.
O of one. It's constant. Number four,
O of n?
O of n. Number five,
whatever n cubed is.
O of n cubic. Yeah.
And-
I forgot the name. I'm pretty sure it's cubic. O of n to the third power. Right. Function with one set of nested loops.
O of n squared.
O of n squared. Function with 10 unnested loops.
O of n.
O of n.
O of n. Correct. Another quiz. What is the time complexity of the following function?
O of n.
O of n?
O of n. Right? Sure, it starts at one, but num can be 1,000, one can be 1,000,000. We don't know. O of n. What about this one? It's a little bit more confusing.
O of n squared.
Why?
I think it would, it would still be O of n for me.
Will it?
Because it has, because like 4 of n, right? That's one, the for loop, and then there's an in. No, actually, it might be just O of n.
Why?
Gonna be squared because the min is looping,
Yeah.
I believe, right?
The min is
So it's a
looping?
nested loop. Yes.
Yeah, because it's having for the n, and then the range is another for the loop.
I
Between like
didn't-
two.
I didn't know what min was.
It's grabbing the minimum number between those two.
It's doing that though through a loop, right? Just under the hood.
I want to say yes, but the number doesn't change. It's just two of them.
I think I'm sticking with O of n here.
I think it's double nested O of n squared.
I guess. Sure,
But I could be wrong.
Final answer.
it's O of one.
Fuck.
What?
O of one. The loop runs from one to whatever this is, right? Which means the number of iterations is at most 10, right? It's gonna grab the minimum number, right? No matter how big num is, it's gonna be grabbed 10 every single time because we're grabbing the minimum number, right?
Oh,
Num
okay.
could be 1,000,
So
but 10. Make sense?
10's always gonna be less than.
Yep.
Yeah, it's like that, the PDF book you sent us. It's like the first thing they talk about is the searching, and I think you actually used that as an example earlier. Where like if you were guessing a number from 1 to 100, you would get rid of anything that was higher
Yeah.
than your number.
All of one. Crazy, huh? Very confusing. What is the time complexity of the following function?
I think this is O of n squared.
O of n squared, correct. Space complexity. So far, we have focused on time complexity, how we analyze the runtime of an algorithm as the size of the input increases. We can also use big O notation to analyze the space complexity of an algorithm or how much additional memory the algorithm uses when it's executed. The question, what is time and space complexity of your solution is actually asking for two big O values, one for time and one for speed. I don't know what that's it. All right, space complexity example. What is the space complexity of this?
Four.
Oh, one?
No. It is O of
I
n.
think 4, cause,
Four.
Oh,
What do you mean
Wait.
four?
well, cause it says deals with how
Oh.
many variables or elements you are
Is
storing.
it 2?
It
Because
is
total is
because
variable
of
and
num.
num is what?
Num. Right, num.
Yeah.
Four. That wasn't even in the chart. Okay. Let's see.
wait, so what was the answer on this one?
Oven. With the n being the size of num. Cool. What is space complexity of the following function?
Would this also be O of 1?
Why?
Because we're only manipulating the list, the new list.
It is oven. Where
The
n
O of
is
n
the
because
length
the range
of the input,
function.
yeah, of R. Right, so the input size, or the input space of R takes O of n space, where n is the length of R. There's three different types of spaces. There's input space, output space, and auxiliary space. The output space is the space used by the new list variable to store the doubled elements. The auxiliary space is not being used here because we're not using any additional data structures. But don't worry too much about it. Just know that it's O of n because the size of R. What is space complexity of this function?
O of n. Just
O of n, correct. What is the space complexity of this function?
O of 1?
O of 1. Didn't we already say this one before?
O of
I
1.
think.
But we're looking at space instead of,
It is because of
Uh,
space, but the space is no higher than 10.
right,
Oh.
Space complexity tips. Remember broad terms. What happens to the number of variables, elements being stored or tracked as the input gets really big? Most primitives, booleans, numbers, undefined, and null are constant space. If a number is a million or one, it is still constant space. Strings require O of n space, where n is a string length. References typically are generally O of n, where n is the length for arrays or the number of keys. The whole string thing, I don't know if you guys are tracking this, but even though it's a string, sometimes not the entire string is stored in one area. Were you guys aware of that?
What the frickin' frack? Would that be like security stuff for hashing?
I'm not quite sure. I learned that when I was learning Java. But not the entire.
Yeah, it's using pointers, right? Memory pointers.
Mhm, correct.
Oh, I hear about that a lot when people talk about C++ too. Pointers. Oh, thank you.
The graph again. I don't like this graph, but here it is. Logarithm explained. We had discussed some common complexities like O of 1, O of n, and O of n squared. Sometimes big O expressions involve more complex mathematical expressions like O log of n or O n log of n. So what is a log or algorithm? It is the opposite of an exponent. Here you have a small little description of it. Log base 2 of 8.
I'm not gonna lie, this log stuff gives me PTSD
Why do you say that?
from going to school. It's just it always boggled my mind with log and natural log and all that crazy jazz, you know. And then when you put into like calculus or whatever, you just memorize it and you dump it. So first time
yeah.
I've seen this in like I think 8 or 9 years, 10 years maybe.
Log base 2 of 8, right? The exponential is 2 to the third power will give you 8, right? So 2 times 2 is 4 times 2 is 8. Logarithms continue. There's a lot of log bases, but not just base 2. But for our purposes, we would treat all logs the same. Remember, we just care about the big picture. A rough rule of thumb, the logarithm of a number measures the number of times you can divide that number by 2 before you get a value that is less than or equal to 1. And it's not always going to divide cleanly, right? So this kind of gives you a small little description of how I was describing to you earlier. The number 8, we divide in half, it gives us 4, the first iteration. The number 4 divided in half gives us the second iteration. Divide 2 in half gives us 1, that's a third iteration. So log of 8 is equal to 3. Make sense? How many times we can divide it by 2? We're just going to be working with the 2. Why are logs important? String and searching algorithms have logarithmic time complexity. Some of the more efficient, better algorithms involve logarithms, most notably binary search, which is a common search algorithm used in technical interviews. Right? Recursion at times involves logarithmic space complexity. We'll cover recursion a little bit, but not too much, just enough to kind of understand the conflict, what's the word I'm looking for? The concept. Logarithmic time and space comes up periodically, so it's best to be familiar with it. You don't have to be an expert, however. All right, so at the end of this lesson, you're not going to be an expert in all this, but it's enough to expose you to different types of data structures and algorithms to assist you in thinking critically, and as well as completing some of these famous LeetCodes problems that you see on YouTube. In a nutshell, Big O notation is used to analyze the performance of an algorithm. Right? Big O notation can give us a high-level understanding of the time and space complexity of an algorithm. And Big O notation doesn't care about precision, only about general trends as the input gets really big. The time and space complexity of an algorithm depends only on the algorithm and not the hardware used to run it. Right? Now, when you start doing LeetCode problems, some of these LeetCode problems, the more advanced ones, will tell you specifically what type of time complexity to have it run it. or space complexity. So now you'll have an idea whenever you see it. Study this graph. I don't like this graph. Dictionaries and lists in terms of big O. All right. So here you have an explanation of what some of these under the hood things are doing. Insertion for dictionaries. This is gonna be all for dictionary O of 1. Right? Typically because when you insert a dictionary, you insert it by keys, right? So you assign it a key, and then with that key, you assign the value. So it's going to be constant. Removal, constant as well, because you're grabbing it by the key. Accessing, you're accessing it via the key, right? Searching is going to be O of n. So when we did our little for loops for key in, dict dot keys, or for key and values in dict dot items, or if and whatnot, like all that searching whenever we're going through it, O of n. Dict dot keys, O of n. Values, O of n. Items, O of n. List, inserting at the end, it's gonna be O of 1. All right, so the append is putting at the end of it. Insertion at the beginning, O of n, because you're just pushing everything to the side. Removal at the end, O of 1. That's going to be instant because you're just grabbing the back end. Removal at the beginning, O of n, because of pushing everything to the left. Accessing, O of 1, using index. Searching, O of n, having it loop through the entire list. Sorting, O n log n. Sorting is one of the methods you can use. That's how it does it for you under the hood. You usually don't see it. Slicing, O of n. And filter, reduce, map, O of n. Right, because they do something very similar. They're looping through and doing something to the list, right? Whether you're filtering, grabbing stuff as you go through the entire list, reducing it, or using map. More of your higher end functions. Big O notation questions.
For the actual boot camp, is this something that we're gonna have to like be using, or is it like a requirement to like
It is.
learn all this stuff?
It is not a requirement. It will be covered a little bit more in depth than what I am doing. You will see this again. You will get more assignments to work on it, and whatnot. But it is not required. It's not tested. The immersive program tests for your if you're capable enough to actually make your projects, right? So like if you know object-oriented programming, that's what's going to be tested. How to use what you call it, Postgres, right? What else is tested? Using React, using Django, and then the fifth assessment is you're putting it all together. It will be your personal project, right? Ensuring that you use React, Django, create your own API, and use a third-party API. Right, I think those are like the 4 requirements. But you are not needed to know or be good at any of this. It's to prepare you for the first gate in your interview process. And I did mention this before at the start. You guys should be doing LeetCode every single day, even if it's just one problem every single day. Because when you start the immersive program, although you will cover it a bit, you'll get some tries at working on LeetCode, learn a couple of algorithms. Once you get past like the first 2 weeks, you rarely touch this. It'll be all revolved around the curriculum. So actually learn how to use Postgres, learning React, and then learning Django, and then creating your personal projects. And then after personal projects, there's group projects, which is voluntary, because it's typically like close to the end of the cohort, and If you're still in the army, a lot of people have like requirements like out processing. Sometimes they're doing that during that time or moving. So the group projects are voluntary. But because of that, you don't really do too much of these leak code problems or just problems in general working with the algorithms too much. So you'll go months without touching it. And then you graduate, cool, you got your portfolio built, but guess what? You haven't touched in a while, and now you're applying to interviews. And as much as we all hate it, that's how they see how capable of a developer you are. Cool. All right, 10-minute break, and then we'll come back, finish off the last hour, and move on with the lesson.
I should be host.
All right, we're gonna go ahead and come back. Brandon had to take off for a personal matter. That's fine. We'll keep moving forward. Last hour of the night, we'll do an assignment or two, and we'll call it. So common problem solving patterns. Not the silver bullet to solving all coding challenges, just some helpful patterns to be familiar with. We will cover these 4 patterns, but there are many more. A lot more advanced than what we're going to cover. But this is enough to get you to start thinking critically whenever you're coding. And take things more into consideration when you're solving or thinking about how to go about to solve your problem, right? You know, instead of doing that nested for loop, think about a much more efficient way of doing it, or instead of lists, thinking about maybe using a dictionary instead. All right, so frequency counter, modal pointer, sliding window, and divide and conquer. The frequency counter pattern. So this pattern uses dictionaries to collect values slash frequencies of elements. All right, we see a small little description here. We have a list that has the numbers 16 to 19 repeated multiple times. They create an empty dictionary called frequency, which they're going to use to store their data. They begin a for loop to go through every single item within this list. And as they go to the list, they are adding it into their frequency dictionary with items, all right, which is essentially the list as a key. And then they're doing new list dot count items. This is not actually efficient. I don't like it, but we'll talk about it in a bit. Right? They use the dot count to count how many times it appears in the list, and they save it within your dictionary. Then they loop through the items inside the dictionary, and then print count frequency, and then the frequency of the actual item. And you see it right here, right? 16.2, 17.3, 18.2, 19.3. Not the best way of doing it, but here's a small explanation of it. This pattern can help you avoid the need for nested loops or O(n) square. To be completely honest with you, I think this is O(n) square. The count method, I kind of have to look that up real quick. Let me check. I'm pretty sure it is O(n) square. Yeah, it is O(n) square. Because this is O(n). So for every single item here, that's a little confusing. I don't know why he would put it this way. I'll fix that, but I'm pretty sure this is O(n) square because they're looping through the items in the list and then counting the frequency of it, assign it to items, which doesn't make sense. It's a nested for loop. Unless he's showing what it did before and he's trying to say to use a more efficient manner. I don't know. We'll figure it out. Student practice, frequency counter.py. Give it a try, boys. All right, let's go ahead and give this an attempt. Let's see, was it 11 or 12? 12 frequency counter. Okay. Let me share my screen. All right, so we have to write a function called same, which accepts two lists. The function should return true if every value in the first list has its corresponding value squared in the second list. The frequency of values must be the same. All right, so we're gonna go ahead and create our function, define same, and it's gonna take in list 1 and list 2. Now, we have to make sure that they're all the same. So, first and foremost, we should probably check if the length of the list is the same or not. It would make no sense to try to do all this if list 1 has 10 numbers and list 2 has like 3. So, we're gonna go ahead and just do that check real quick. If not, then we're just gonna go ahead and return false. If the length of list 1 does not equal the length of list 2, return false. All right, that'll take care of that edge case. Next is we want to check what the frequency of our list is. So we'll do list 1 frequency is equal to an empty dictionary. List 2 frequency as an empty dictionary, and then we'll loop through the first and then the second list. So for num in list 1, if num is in list 1 frequency, then I want to increase the count by 1, right? Else, I want to assign the count to 1. Right? So what this is going to do is going to loop the list. Hey, it's in the dictionary. It is? All right, well, let's increase that number because we've encountered it before. Right? And in the event that I don't find it in here, I'm going to go ahead and save it in here with a key. Num being the key, it's a unique number. And then set count to 1 because it's the first time that we are seeing it. Right? And we're going to do that for both these lists. So for num in list 2, if num in list 2 frequency, then increase the count. Else list 2 frequency, save num as 1. All right. So that'll create my dictionary that has a track record of the amount of times that this number has appeared to us. All right. Now, I can begin checking the frequency of the numbers and seeing if squared they match the number and the other frequency. So we'll do for key in list 1 frequency dot keys. All right, I'm gonna loop through the first one, and I'm going to check if that key is in the other dictionary squared or not. Right? So I'll do if key squared, right? If you guys remember to do a square in Python, it's the 2 asterisks, is not in list 2 frequency, then I want to return false. That means it doesn't exist, right? As an example here, we have 1, 2, 3, and 4, 1, 9. 1 square is 1. It would appear here, so it would pass that check. It wouldn't return false. 2 square is 4. It would pass. And then 3 square is 9. So it would pass. None of this would return fail when it checked the other list. this one right here will return false right off the bat because there's the wrong length. And then over here, this will return false because this would check if it's in here, it would check once one or not, and then it would be in there. And 2 square, it will return one out. What you call it? But if it's not, then it won't essentially return it, right? But then we also have to check for that specific reason. So we are gonna do if list 1 frequency, we're gonna grab the key, right? That key will return to us a value, does not equal the frequency in list 2. And this one would be squared, then we return false, right? Now, why is that? Well, because this is going to check if it's even in there or not, right? If the square one is not in the list 2 frequency, this one will check the value of it to check the frequency to match as well, right? So it's cool that 1 is in here, right? But how many times is it appearing? Right here we have it twice, and here we have it once, right? And we want to ensure that we take into account the frequency of that number. All right, this needs to appear twice in here. And if it's not appearing twice, then we have an issue, right? And that'll take into account the fact that this one has 4. When it should only have it once, but it has it twice, as well with the once and vice versa, right? And up to this point, if we have not returned false, if it's made it this far into the code, then all we have to do is return true. Because at any point, if any of these checks would have failed, then it would have returned from the very beginning, right? To false. Now we can do the print. We'll call the same function, and we can pass in a list. This will be 1, 2, and 3. And then this list will be 1, 5, and 9. Let's run this bad boy. Lesson 12. And then we want to go into frequency counter. Python free. All right, and it returns false. Why? Well, because 2 should have returned. It should have the 4 on this side, but it does not have it. If it was 4, then it would return true. Right?
So, I think a way to maybe even optimize it further. So like if you're looking at line 16, I think it would make more sense to rewrite that immediately after line 3 and put that on line 4, because essentially you already have an array with those keys. So you could do the same check and you can say, if the num isn't in list, or if for num in list 1, if that num squared isn't in list 2, return false, right? Am I thinking about that right?
Are you talking?
Because you're essentially going from. I feel like there's an unnecessary step in taking line 16, 4 key in list 1 frequency dot keys. Right after that, you have if key not in list 2 frequency. Since you have a list already in list 1, couldn't you also just do that check earlier in your code, just using list? Whether that there's a key squared is not in list 2 frequency. I don't know if I'm explaining that right.
You're talking about over here, like as we take care of list 2.
No, so look at line 17.
Yep.
So you're checking if key squared is not in list to frequency.
Uh-huh.
You could do that same check just on using the list that you're given, right? You could say, you know, for num in list one, if num squared isn't in list two, return false,
It's
right?
would
You
be
don't,
it would be a nested for loop. Right? Because if I were to do it here, right? And I'm trying to search, right? Because that would be searching. When you do in a list, it is searching. It's not using an index. All right. I can do it here, or I'm sorry, right here, because when it's checking inside of a dictionary, because that's what list two frequency is, the dictionary, it's gonna use it as a key to find it. If I were to add it within this for loop in this list, it would use a searching type of method where it's looping through it, therefore making O of n square the entire thing. Up to this point, this is O of n.
okay. I think
Does
I'm
that make
tracking.
sense?
Yeah, no, that does.
Is it a little bit extra code? Yes, but it is still more efficient than doing that check in here, because I now just increase the amount of iterations that my code has to do. It increases the time complexity. So less code doesn't always mean better code, right?
Yeah, no, okay, I got it.
Sam? Cool.
I got
Next. So a not so great solution, right? They do list one, list two. They're checking if they equal the same or not, just like we did, returns false. Right, pretty straightforward. Here they do for I in range of whatever list one is. They square that number. And then they do if square num not in list two. And why is it not so great? Because now this is a nested for loop. This is what you just recommended, Eric. Right? They're checking.
they
the only-
just that's what I did.
yeah. It's not that it's wrong. It's gonna give you the right answer, right? But it's not that good of a solution because you're nesting for loops, therefore increasing the time complexity because now you have to do these many iterations for these many iterations, right? O of n squared is gonna take a lot longer than using dictionaries to get constant time when checking for stuff. That was the point of the dictionary. It allows you, it's like creating a map, like a hash map of your data, which makes it easy. Dictionaries are significantly better than lists because of the fact that they have key value pairs, which are easier to access than a list would be. It don't matter if your dictionary is 1,000, right? If your dictionary is 1,000 or a million different key value pairs, it will still be constant time because you're using the key to go directly to that area. Whereas a list, it will be O of n if it's 1,000. Worst case scenario being 1,000 iterations. Right, that is why dictionaries are significantly better and why you want to avoid this. This is the same thing that you recommend, Eric. Only difference is right here that they separated the code instead of doing if square num squared not in list two. Right, that's kind of what you recommend. Am I correct? So not so great solution. You don't want to do this. Can you? Sure. But the previous way was it's better. Right? A better solution. This is literally exactly what I just did. So they create the two dictionaries that they use to kind of map out their frequencies, and then they use the dictionaries to compare. Essentially, instead of comparing from two lists, you want to compare using dictionaries instead, right? And dictionaries gave them the ability to even save the frequency by the key values, right? So that's all you did. You essentially just transfer the data from a list to a dictionary, added additional values, which kept the count of them, and then you're comparing the dictionaries instead of doing the list. The in operator in Python is O1 for dictionaries, but O(n) for lists. Right? Gotta emphasize that. So next time you guys are working on your questions, think to yourself, like, do I want to use a list or can I use a dictionary? How can I use a dictionary instead to better improve the effectiveness of my code? Right? It'll increase your time complexity. Run this bad boy in a LeetCode problem. If you guys have used LeetCode, right, you can, at the end of it, it'll show you the time and space complexity. You'll see people like where your code falls in line with other people. It'll show you how fast it is and how slow. And you'll see that if you were to use nested for loops all in square, you're gonna be in the bottom range of everybody else that use dictionaries, significantly faster. And typically when you look at the time complexity on these LeetCode problems after you submit your solution and you check those solutions that have the best time, they're gonna have some form of code that is either surrounded around O1 or at the O of n squared or log of n. Right, the slow ones are gonna have like nested for loops, O of n squared and whatnot. I meant when I talked before, I meant to say O of n. So it has either O1, O of n, or log of n. The worst ones have n squared or worse. Right, n cubic, horrible. But yeah, you'll see them. You can check the solution, see their code, and you'll see the difference between them. We're gonna stop here, because I want to give you guys enough time to actually do the problem and talk about it. I would hate to stop halfway through and not give you guys enough time. We're gonna continue this tomorrow. But if you guys are having issues understanding anything that we covered today, I would like for you guys to really check out that book. Even if it's a chapter per day. A chapter per day, within now and the end of FOP, you'll be done by the book and you will understand most of it perfectly. Because we're gonna keep doing this week and next week. Right? And then once we get through the whole curriculum and we're done with assignments, it's gonna be doing LeetCode problems together. For time, seeing solutions and whatnot, just working until you guys start the immersion program. So from here on to the rest of the FOP, it's gonna be algorithms and data structures and trying to find better solutions of doing stuff. So read a chapter a day, you'll be done with it by the end of FOP and you feel good. I promise you. All right, well, we'll end it here. Thank you guys for coming. If you have nothing else for me, I will see y'all tomorrow.